Good morning, guys. So our focus today is going to be on seasons and what causes the seasons here on Earth. Teak 8.7a model and illustrate how the tilted Earth rotates on its axis, which we talked about last week, causing day and night, and revolves around the sun, causing the changes in the seasons. So when we talk, generally speaking, the seasons are caused by two things. One, the tilt of the Earth's axis, and the changing positions of the Earth as it revolves around the sun. Okay. So, first off, let's just focus on the Earth itself. One of the reasons for the season is the 23.4 degree tilt of the Earth on its axis. Now, throughout this unit, different activities, different books you would read, different websites you would look up, basically you're going to see different numbers: 23.5, 23.6. This thing right here for some reason has 21.5, which to me is incorrect. So just know it's 23.4. That's what you'll be tested on if you ever see it on a test. 23.4. So you see here there's a picture of the Earth that it's tilted. The Earth is also rotating like it does, and you can also see the incoming solar radiation. So as we look at this would be summer in the southern hemisphere and winter in the northern hemisphere. So before we go any further, just keep that in mind, that in this arrangement with the axis in the northern hemisphere tilted away from the sunlight, this would be winter in the northern hemisphere and summer in the southern hemisphere. So let's just quickly review the hemispheres. Of course, it's a new word, I guess, or shouldn't be a new word because you all learned a lot of geography in sixth grade. But the Earth can be divided into four parts. We're not worried about the eastern and western hemisphere because those don't factor into the seasons, but we do want to make sure we understand the northern and the southern hemisphere. We also need to know that that dividing line between the north and the south is the equator that runs across the Earth. It is a line of latitude, and as we mentioned on Friday, how far north or south of that line you are determines the length of your day. So again, we need to make sure that we understand the northern and the southern hemisphere and where that cutoff is. So if we look at the Earth on this side, we can see that it runs right through Africa. And then on the eastern hemisphere or the western hemisphere where we live, you can see that the equator runs through South America. Okay. So again, just to focus, the hemisphere tilted towards the sun is going to receive more direct radiation. This season is summer. So in any model that you see, and I'll show you a couple of different models in the video, any model that you see, if one of the hemispheres, either the northern or the southern hemisphere, is tilted toward the sun, the season on that hemisphere is summer. The season on the hemisphere tilted away from the sun is going to be winter. So if we look here as to the reason why, what we call direct radiation. So if this energy coming from the sun is heading towards the Earth, if you're in this hemisphere, then basically what's happening is it's like getting punched straight in the face. Okay. The sun's energy is hitting the Earth straight on. And that's a much more powerful form of energy transfer. Whereas the energy that's hitting the southern hemisphere is giving it kind of a glancing blow. It's not hitting it really head on. It's hitting the Earth and kind of deflecting off into that region. So the majority of the northern hemisphere, remember that the Earth is spinning, okay, once every day. The majority of the energy from the sun is focused on the northern hemisphere in this arrangement. And that would mean that it would be summer in the north. In this arrangement, when the hemisphere or the northern hemisphere is tilted away from the sun, then it's getting that glancing blow of energy, but the southern hemisphere is getting the direct hit of that energy. So this would be summer in the south and winter in the north. And again, remember that if the arrow that you see here on the video is here, the Earth is rotating like this all the way around and to the back once every day. Okay. So let's talk about the specific arrangement or the points that the Earth is at during its year. Around June 21st or 22nd, we call this day the summer solstice. Okay. This is where the sun reaches its highest point in the sky, and the length of our daylight hours are the longest. All right. So our longest day in the northern hemisphere. Again, all of this is, we're talking about where we are here in Texas. So all of these dates and times and dates and seasons that we're talking about are applicable to only us. Okay. It would be opposite in the southern hemisphere. The dates would be the same, but the seasons would be opposite. So June 21st or 22nd is our summer solstice, the first day of summer, the longest day of the year. Okay. This is the position that the Earth is in that on that day. Okay. You got the Earth's northern pole here pointed directly towards the sun. The south pole here is pointed away from the sun. So again, a much larger portion of the northern hemisphere is aimed at the sun, and a much smaller portion of the Earth's southern hemisphere is at an angle, creating less or indirect sun rays. Now, 6 months later, on December 21st or 22nd, depending on the year, is our winter solstice. This is our shortest day. Okay. The length of the daylight hours are the shortest. All right. So here again is the position of the Earth relative to the sun. You see that the Earth's northern pole is pointed away from the sun. The southern pole is pointed toward the sun. And I want you to also notice that as the Earth rotates, okay, you notice that the sun would never hit the North Pole, and the sun would never go down on the South Pole. And then going back to the summer, the sun would never set up here in the north. It would be daylight all day for 24 hours. And then in the southern, on the South Pole down here, it would be nighttime for 24 hours. Okay. So the other 2 days are March 21st through the 23rd, again, depending on the year, and September 21st through the 23rd. So these are what we call the fall and spring equinoxes. So this is when the axis is neither pointed away or towards the sun. It is what we call perpendicular to the sun. And so each hemisphere is receiving the same amount of radiant energy, and the length of the daylight and nighttime hours are equal, hence the word equinox. Now, you may also hear the spring equinox referred to as the vernal equinox, and the fall equinox is sometimes referred to as the autumnal equinox for the word autumn. So again, equal hours, day and night. Okay. Earth is not tilted away or towards the sun, and both the southern and northern hemisphere are getting equal amounts of solar energy. It would be spring in the north, and then if it's spring in the north, it would be fall in the south. If it's fall in the north, it would be spring in the south. And if you think back to, and it's hard here in Texas because we don't really have 4 distinct seasons, but the weather during the spring and the weather during the fall are basically kind of the same. Okay, as far as cooler temperatures, cool at night, not as hot during the day, but the same in the spring and the fall. So I do want to show you 2 different diagrams, because on a test, and I know this isn't very clear, but on a test, you may see it 2 different ways. So I want to make sure that we cover this. So in this arrangement right here, first of all, the Earth always goes counterclockwise. And these arrows kind of help you understand what counterclockwise is. So if we can pick any one of these 4 locations to start. So if we pick here, this is the first day of summer, right? So we have the North Pole pointed towards the sun. The South Pole is pointed away from the sun. So this is the first day of summer in the north and the first day of winter in the south. Now, the Earth then, throughout its orbit, starts moving in this direction here. So if this is summer, then we will be heading into the season known as fall. So this would be fall, the first day of fall. Notice that the axis is pointed this way, not towards the sun or away from the sun, but perpendicular to the sun. All right. So again, equal hours, day and night here, first day of fall in the north. This would be the first day of spring in the south. Then the Earth continues its motion around counterclockwise until it gets to December 21st, 22nd. This is our winter solstice, the first day of winter. Notice that the North Pole is pointed away from the sun. The South Pole is pointed towards the sun. First day of summer in the south, first day of winter in the north. And then the Earth continues its orbit 3 months later till the vernal equinox. This is the first day of spring in the north because we're transitioning from winter towards summer. So this would be the first day of spring in the north and the first day of fall in the south. Now, again, this is one diagram. If we look at this diagram, notice that the axis is different. So if you look right here, this is the December solstice, but in this diagram, the December solstice is on the left, but in this diagram, the December solstice is on the right. And really all this means is that you're changing the position of your perspective. You're on the opposite side. And so if you're on the opposite side, this is how you would see it. Nothing changes. The Earth is still revolving in a counterclockwise direction. But how you're going to have to make sure that you understand it is not to memorize that winter is on the left or the right, or spring and fall, or top and bottom. You always have to look at the axis. So whenever the axis, the northern axis is pointed towards the sun, that's going to be summer. And then from that point, you can extrapolate the rest of the seasons, knowing that the Earth is rotating in a counterclockwise direction. So if this is summer and we know that the Earth is going this way, the season that is after summer is fall. So this would be the first day of fall, the first day of winter, the first day of spring. But in the other diagram, if we start with summer, okay, again, going in counterclockwise direction, summer, fall, winter, spring. So it's opposite because of the way that the diagram was drawn. And that doesn't make this diagram wrong. It just makes it that this diagram was drawn from a different perspective. You're on the opposite side of the solar system. There's a video here you can watch to kind of help you understand things. Okay. So one more thing I do want to go over with you, again, harking back to that different diagrams. You'll see this activity a little bit later on, where you'll have to identify winter, spring, summer, and fall for these locations. So you have this diagram, and then on this other diagram is the same diagram, just with the axis is tilted in a different direction because you're on the other side of the solar system. Okay. So again, we'll spend some time in class talking about that over the next couple of days. You'll have a couple of activities that you'll have to do to show that you understand when the seasons start and why the seasons start, and then what is going on during those seasons. Okay. And remember, the difference between summer and winter comes down to direct and indirect sunlight. Okay. So in this situation, it's summer in the north because it's getting the direct hit right square on the northern hemisphere. It's winter in the south because the sun rays are a little bit more indirect and more of a glancing below. All right. If you have any questions, as always, let me know, and have a great day.